So saving it as side cutter demo or whatever. What's the first thing I'm going to do? New component, global rule 1, or just rule 1. And I'm going to call this, whatever, I'm going to leave it component 1. I don't care what it's called right now. I just want to make sure I'm working inside of a component all the time. And then I'm going to do insert. And I'm going to insert a canvas. And a canvas is just like a reference image. And I'm going to find, insert my computer. I'm going to go to downloads. And you can pick the face. I'm going to pick the down. I'm going to pick the down-facing face. But it's up to you. And then just click OK. Trying to scale it here is a big pain in the butt. We don't know. It's not as good as scaling it later. So you should have an image on your screen. Levi, do you want to walk around and see what people are doing? The insert canvas. Do we have these here in the shop? Do you know? Okay, so let's just pretend we know how big it is. I think it's like 4 inches or so. Oh, here we go. Wait a minute. Let's do some science. Copy image. Illustrator. Control new. So here it is on a grid. Oh, but is it a metric grid or is it a? We'll never know. I think these are as a 10 millimeter grid. I'm just gonna try to figure out how big this thing is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ignore this part. I'm just trying to figure out how big the actual tool is since we don't have it here. With 10 millimeters. Okay. 4.38 inches. Let's pretend we had the tool with us, but we don't. But I just measured it based on that photo, which was on a grid. And so you want to open the component. You want to open the canvases folder. You want to find the image. And you want to click calibrate. And then you're going to click one point, and then another point, and you're going to tell it how big it's supposed to be. And in our case, it's 4.3 inches. Let's just do 11.2 or 111 millimeters. And you're welcome to change your document settings to millimeters. I'm going to. Great. So now this is the same size as the real tool. And I figured that out because I found a picture of the tool on top of one of those cutting mats. And I own this tool, so I know that these are too small to be 1/2 inches. So I know that it's a metric grid. It's a pretty good side cutter. You know, it's not. This other one is like 10 times the price and it's better, but you know, it's just like whatever. It's just a tool. The next thing we're going to do is we're going to do create sketch. And we're going to click that same plane. And then using the fit point spline, and you don't have to be exact, you can be kind of creative. We want to trace the profile of this tool. Yeeks. I don't have a ton of experience using the spline tools in Fusion, but it's going to be similar to Illustrator. So you can just mess around until it looks good. Maybe deleting some points so it's smoother. It definitely doesn't have to be perfect, but I want to, I'm putting this on YouTube, and I have almost 100 followers, and it's really important that I don't disappoint them, So at this point, what we've done is we've inserted a canvas. The canvas is of the Hako side cutter. This one from Home Depot. It's out of stock. Bummer. We've calibrated that image from here to here to be 111 millimeters. Then we've created a sketch on that same plane, and we've loosely traced out the profile. Now I'm going to click Finish Sketch. And we could use like the solid tools. Like you don't have to follow this along. This is just like this isn't what we're going to be doing. You could like extrude a block, and then you could hide the canvas, and you could like put a bunch of fillets on it. And like that's not bad. That's comfortable. Like that would work. And that might be what we end up doing. And that's a totally valid way to work, and it's a great way to work, and it's fine. But just for the purposes of today's demo, we're not going to do the extrude and fillet. We're instead going to push this magic purple button. The magic purple button is Create Form. And what Create Form does is it enters us into a new mode in Fusion. As soon as I click that button, now the top says Form, and you might notice it added a purple box to our timeline. Because everything we do while in this mode isn't going to be captured. What T-Splines are, which is what this mode is called sometimes, there's also Form mode, the Sculpt mode, the T-Splines mode. T-Splines are like the three-dimensional version of Illustrator lines. They let you make really swoopy surfaces like bike helmets and like, I guess, skulls and, dolphins and ducks. I'm just trying to prove to you I can identify animals after calling an owl an elephant earlier. And T-Splines are really powerful and really useful, but they're not good for things like cylinders. They're not good for things that are mechanical, which is why it doesn't add things to it only adds one thing to the timeline. It's kind of like a little box that keeps your squishy stuff inside of it. And we're going to go ahead and do Create and Extrude. And notice this extrude is a purple extrude. It's different than the blue extrude. This extrude works instead with T-Splines. And you might notice it's not even close to the curve we gave it. It's just like, what the heck? We gave you this nice curve, and you picked a new one. You can mess with the number of faces until you like the way it looks. It looks like 10 for me, because I think I have 10 points is a good number. Yeah, how are we doing? So if you go to the Create drop-down, it's the purple extrude. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so you should probably have the same number of faces as you have points. So like you see with 8 faces, it doesn't really look right, but with 10 faces, it looks perfect. I'm going to extrude this to 10 millimeters. The sculpt environment's really weird and really powerful and really frustrating at first. But if you want to make like really swoopy things, it's really a lot better than the regular tools in Fusion. I'm going to just take this couple steps further. At this point, I'm going to hide the sketch, or the canvas, and then I'm going to rewind and do it again. You might notice that this is like a cookie cutter. This is 0 thickness. We want to cap that. So if you go to Modify, fill hole. And if you double click, if you click the line, I can do that again. If I click the line once, oh, you just click the line. It kind of fills it. And then I'm going to do that again on the other side. Modify fill hole. Now we have like this kind of sausage thing. This like curvy eyebrow sausage. And remember when I said that T-splines were like the three-dimensional version of... Wait, hold on. I'm going to Control Z once. I just remember that there's symmetry in this part. So instead of rounding off both sides, I'm just going to go to the symmetry dropdown and do mirror duplicate. Does this work? Give me a second. Mirror plane. There we go. Actually, everybody just stop following along for a bit. I'm going to go crazy with this, and then I'm going to rewind and then start over. Because I want to show you why this is cool before I bring you through all of these really annoying steps. So I mirrored it and duplicated it, and now it's a little thicker than our real handle. But now that we have our basic form, I can show you where the real power of this tool set is. It's not just that the old one, the old thing we were drawing, it was a rectangle with fillets, so it had straight edges. And you can see that nothing on this is flat. Everything on this is kind of swoopy and nice. But the really cool thing is if we go into Modify, we can be like, oh, my users told me that this needed to be a little bit fatter here. Oh, I actually 3D printed this and I found that it would be really nice if it was a little bit thinner here. It turns out that there's too much plastic in this design. So I'm going to go ahead and shrink it this way. I can go ahead and, this side is where the hand's going to be. This side here, that can be sharp. And maybe it will look a little bit more modern if these lines here, if these lines are sharp. And you can just go crazy messing with things with very few limitations, It's not at all like the way we typically think about CAD, where it's just fill it, extrude. It's really squishy and really fun. But with great power comes great Spider-Man. Unlike in regular Fusion, in the sculpt environment, you can make really fucked up and impossible things. If I stretch this a little bit too far to here, this is bad. This surface is intersecting itself. And if I click Finish Form, it's going to be no. No, you're not. You're not done yet. So this is kind of the Rhino mode of Fusion, where it's really easy to make the kind of mistakes that will make something impossible to print. So, and we only need to design one of these because it can be the same for both handles. Cool. Okay, so now I'm going to rewind and we can follow along. So we've already placed the canvas. We have traced we've using in the finish form. Delete. I'm going to delete this. So I'm going to do new sketch. I'm going to click this face. I'm going to use fit point spline. A spline is just a way of saying the pen tool. There's two ones. There's fit point and control point. Fit point I find to be easier, but you're welcome to use either. I'm just going to click on the curve, in spots that seem like they make sense. You want to use as few as possible, but you don't want to use so few that it's not enough. It's similar to an Illustrator, like you just kind of get a sense for it. And then if you tap Escape, you can see in my cursor right now, it's in spline mode, but if I tap Escape, it's now in regular mode. Now I can just come in and I can move these, which I think is important because I think a lot of them are in bad spots. Or maybe I don't have enough. I'm not sure. But it also doesn't have to match the tool exactly. We're just using this as inspiration. We don't have to... I figured by having a real tool to reference, then I can wow you with my accuracy. But we're not here to make copies of existing tools. We're here to design our own. So feel free to be like, this is stupid. Personally, I find that the way it flares out in the front isn't necessary. I've never really had a problem with my hand sliding over the top of the tool, which I think is what that's here to prevent. And just while we're here, I want to point out that this tool has an insane number of processes. So it has a rivet here. It has, so there's riveting. The basic shape is stamped out of steel. Then that steel, after being stamped, is bent. After being bent, it's ground to be sharp. I think it's then machined so the hole is perfectly round. They then add a spring that's invisible. It's like a coil spring on the other side. Then they put the entire metal tool into a injection mold, into a molding machine, so they can injection mold the red plastic around the handle. So the steel handle probably has holes in it to make sure that it has a lot of surface area for the plastic to grab onto, and the plastic flows around the metal and actually surrounds it. But once that's done, they have to injection mold it once more to add the rubber. So they put the plastic and metal tool into another mold, and they injection mold the rubber. They're not done yet. They then put it in a laser etching machine, very similar to the one we have, but faster. And they mark it with all these warnings about cut copper only, wear eye protection, here's the brand, here's the model number. Made in Italy? Really? Well, that's cool. I don't know why that's cool. I mean, it's just surprising. So once your sketch is done, it should have not too many points, but not, as many points as you want, really. Go ahead and count those points. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to click the purple Create Form button, which brings us into the purple form mode. Everybody here? Cool. And then Create, and then Extrude. And then we're going to click this line. This time I'm going to do 5 millimeters because we're going to do the symmetry thing. And I'm going to do 9... Wait. Yeah. Yuck. What's going on here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. Wait. Huh, it worked better last time. I'm going to do 13 points this time because for some reason it wasn't really matching before. So just change the number of faces until you like the shape. T-splines really want to be swoopy, so if your base curve is not the way it likes, which apparently it wasn't, it's not going to match. It's never going to match perfectly. But we don't really care because it's an organic shape.
It seemed like under spacing, if that's changed to uniform, then it matches the original shape better.
Oh. Does it? I think the difference is whether it puts it where it thinks it needs them or whether it puts them uniform. But let's do uniform. It'll probably make things easier later on. So I'm just going to do uniform 10. You can also specify a draft angle. Like if I wanted to make 15 degrees or negative 20 degrees, it kind of drafts it in a little bit. That's totally a possibility, but I don't think we need to do that for today. Cool. Now I'm going to click OK. Now we should have this cookie cutter looking thing. I'm going to hide the sketch, or the canvas, excuse me. And I'm going to go under Modify, and and I'm going to select Fill Hole. Again, so we're still in the form mode. Everything is purple. We click the Modify drop-down, and we click Fill Hole. And then you just click anywhere. There are 3 different types of hole filling. I'm going to go with the default Reduced Star. It should be fine for us. And then I'm going to click OK. And now we don't have the cookie cutter anymore. We kind of have this, like, I don't know. What is this? It's half a handle. I'm going to click the symmetry button, and I'm going to do duplicate. So you see there's 4 kinds of symmetry here. There's the 2 kinds of internal and the 2 kinds of duplicate. Duplicate will make a duplicate of the geometry. Mirror will take something that is already symmetrical. Internal will take something that's already symmetrical and just apply that law, so you don't have to worry about changing things all the time. So we're going to do mirror duplicate. Click the body, and then click the same plane that is in the middle. And now we have like a mustache. Yes?
Can we just do like 2-side when you do extrude?
It's not as good, and the reason why it's not as good to do 2-side when you do extrude. Oh, you could have done 2-side when you do extrude, and then internal. But see, if I grab this face here, it goes on both sides. So if I had instead, your question was if I had done 2 sides with extrude. If I go create extrude, symmetric. Oh, cool. Embed symmetry. Yeah, and then that saves a step. That's a great idea. If I didn't embed symmetry and I just clicked OK, this would be an opportunity where we could do symmetry internal and just select the 2 faces. But if instead, yeah, that's a great idea. It's going to be the same effect, but I didn't realize that was an option. So yeah. So I'll do it the way I did it the first time, just for consistency. No, it doesn't matter. It's the same. I'm just going to do embed symmetry. And I'm going to do fill hole. Great. So everyone's at this place, right? They have a thing that looks kind of like this. This like mustache, eyebrow. Cool. I'm going to make a very small change to it just because we can fiddle with it forever. I am going to fatten it up right here. So the modify tool lets you grab either vertices, edges, or faces, and lets you move them, rotate them, or even scale them, which is kind of weird, the scaling especially. And this little gumball widget here, this lets me move it in one direction, this lets me move it in another, this lets me move it in the third direction. These ones let me move it at 2 directions at once. You see how it's kind of like when I mouse over it, it kind of jets out these little crosshairs. This lets me move it in 2 directions at once, which can be useful. These just let me move it in one direction. These just let me move it in one direction also. You can also rotate it with this handle here, which has a pretty subtle effect. But if I instead rotated it this way, it's going to be a lot more severe. So getting used to this gumball can be challenging. I don't know what Fusion calls it. It's called the gumball in Rhino. But it's essentially it's like up, down, in, out, left, right. And these 3 here are scaling. Which scaling doesn't really make sense in this environment, I don't think. Ooh. Sorry, my computer is having trouble. It gets a lot, when you're screen recording, the computer gets a lot slower. Yeah, so I'm going to make the handle fatter by selecting Modify, and then grabbing this line. And then I could either do it this way and then this way, or I can combine those steps just by grabbing this handle. And you might notice it starts to get weird. Like, nobody wants it to have have a pucker there. But we can just click, we can be done for now. And then we can actually select this line, even though it's the symmetry line. And we can do the same thing here. So now we have like a tool for a child, you know, like really big grips and that kind of thing. There's also this option called soft modification. I like this option a lot. You can see this kind of puts a gradient across the model, like the red to white, and makes the modifications affect a larger area. So if you want, if what you want to do is like to make, you know, if you want it to not be so localized, you can use soft modification. And feel free to make any changes you want. You know, like this, you know, it can be sharp here. Yeah, and I'm going to add a crease also. So I'm gonna click OK on Edit Form, and I'm going to go to Modify and then Crease, and I'm going to add a crease here and here.
If you select from your duplicate function and then you click on your object and it doesn't mirror, then you need to something around it.
You have to, the second thing you click has to be the mirror plane.
Oh, mirror plane.
Yeah, and then click that one. No, try OK. Oh no, T-Spline body, select, and switch your body. There you go.
Oh, I see it.
It has to switch your things.
Yeah, no, it's over.
Yeah, one thing that I find really frustrating about Fusion is sometimes these windows, anytime there's a window open on the right side of your screen, it needs you to do something. And sometimes like people push this little button and then can't see it, and they're like, "What's going on? Why isn't any of the other buttons working?" It's because this is still waiting for input. Like for example, like T-Spline entity, you have to select the T-Spline entity, and I never minimize this because it's like, you know, either I want to do something or I don't. But as long as that window's open, like, you know, I can't do anything else. I'm gonna undo those creases because I think that they're actually. Wait, actually, is it uglier or less ugly? Creases or no creases? What do we think? Creases? Cool. I'm just going to say creases. Finish form. So now, you might notice that all those steps that we did weren't recorded. Like, you know, normally, you know, like, I can do all these things to the creepy face. Give it a second. It's thinking hard. The creepy face model is a very complicated model. I should have saved. I'm going to save this. Just I don't want to lose it. The creepy face model, you can see I was doing all these complicated things. I was trying to make it hollow and like break it in half into like a weird like candy cup. And I can go back in time through all these things, but notice that the place where I actually made the creepy head, there's no history there. It doesn't capture the history. That entire history isn't recorded. So if you wanted to change the form, you can either go back into Edit Form mode by doing Edit, but you can't like go back and change the length of your extrude because that was in purple mode. It's not that important of a distinction, but like I thought I'd mention it. And now that we're outside of purple mode, you might notice that this is just a regular body, just like everything else. I'm going to turn the canvas back on. And now I am going to, I want to make a plane down the middle of this. So I'm going to do New Sketch, and I'm going to again click on the bottom face. Oh wait, I don't think I have to. Hold on. Oh great, yeah, it's already there. So we have this. The way the image came in is perfect because it centered itself, which means that to make another handle, we can just do Create, Mirror, Pattern Type, Components, And then we click the component here. And then for the mirror plane, we can just select this plane, and you can see the ghost of the new component. So again, I'm going to start that over. Create, mirror, pattern type. There are a bunch of different pattern types. We want to do components. I want to select this component. And then for the mirror plane, I want to select that plane. Then I'm going to push OK. And then I'm going to activate the top layer. I'm going to activate push the, and I'm going to hide the canvas and hide the origin. Oh, that's funny. It mirrored the canvas also. Didn't think of that. Starting to look like a tool. It's just missing its business end. Cool. So now I'm going to make the canvas visible again. I'm going to again click New Component. And this one's going to be called Top Blade. I don't know that these are called blades, but there's a top one and a bottom one from our point of view. And I'm going to create a new sketch. And I want to make sure, I'm actually going to finish this. I'm just going to take a pause here because we did a lot of steps just now. So I'm going to walk around and make sure folks are here. So we should have two handles on an image of the tool. I need to be smarter about this. I'm going to do that every time I get up unless I just move the cord. There we go. Also, drink the coffee. I don't touch the stuff, so it's just going to go to waste. So go ahead and click finish sketch. I think you would just start from the sketch part. So now create here. And then change places to component. And objects, click right here. Oh yeah, you put that. And then mirror plane. That one. Cool. And then if you mouse over on save, you'll see the little secret dot. Just to everything take at the top level. And now save. I want to talk a little more about the secret dots. My biggest problem with Fusion 360, and something I tell everyone who works in the Fusion 360 when we have lunch sometimes, like they all come out and I'm just like, everything's great except for the things that aren't. These dots, which do not exist until you mouse over them, which is like obviously a horrible UI. It's like all elements of the UI should be visible at all times. Is really important. What this dot is, and if you mouse over it, it'll tell you, it says activate component. This tells Fusion which component you're working on and will determine where anything you do lands. And you want to make sure that when you're working on, handle 1, mirrored handle, that you have that activated, or else you end up with a really messy model. Like right now, if I go to inspect, you can see that the stuff I did to create the orange component is color-coded orange, and it landed in orange. And I haven't done anything to this component yet, so there's nothing for it other than the mirror. So yeah, these dots are really important, and yeah. It's also a good idea. So where we should be at is you should have two grips. It doesn't really matter so much if they're in the right place. That are each a different component. And your screen should look more or less like this. Again, all this is going to be up on iLearn by the end of tonight, and you can use this to get caught up. I'm gonna now I made a new component by clicking new component called top blade. I did that earlier, so this component is here. It's automatically going to activate once you have a new component, but you want to make sure that when you do click new component, that you have the top level, the name of your file activated, or else it will land inside of another component, and that's not what we want. So for now, you should have a component called top blade selected and activated, so everything else should be kind of ghosty. I'm going to do new sketch, and again, I'm going to click the bottom plane. And now I'm just going to use the line tools instead, because we don't need to use the curvy tools now. And I am going to just kind of trace this top piece. So yeah, this is a loose trace of the top piece. I'm just going to move these lines until I'm happy with them. Something I've just realized is that in order for this to work as a tool, this line here, it can't be anywhere. It has to be what's called radial with this hinge. Because if this line doesn't point directly at the center of this hinge, then when these two things come together, they're not gonna be flush. They're not gonna be closed. So I'm also gonna make a circle. So I'm gonna make a line from the center point, which on my thing happens to be like pretty much the center of the thing, all the way up. And right now this is a regular line. You can tell because it's solid, but I want that to be a construction line. So I'm going to click it, and then in the sketch palette I'm going to click the construction button, and now it's just a reference line. And the reason I did that is just because I wanted something that was locked to this origin point, which for me happens to be related to the center of my piece, like between the two handles. Just so I can, when I make the circle, it's on that line. And the circle, its size also doesn't, actually no, its size doesn't matter, because it's going to be the hole in the blade. So I'm going to put a dimension on that circle of 3 millimeters. And then I'm going to draw a line from the center of that circle just out to anywhere. And then I'm going to move it inside. I'm going to make it a construction line. Because I don't want to use this geometry for anything except I want to drag it here. And then I want to get rid of this little kink here. See this little bend? So I'm going to select this construction line and this line. And I want those to be part of the same line. And for that, the constraint is called collinear. And what collinear says is it's like, two things can be parallel. Two lines can have no relationship. They can be parallel, which means they're going in the same direction. That they're never going to cross, but they don't have any spatial relationship to each other. So this is parallel. Or they can be collinear, which means that these two line segments are actually part of the same line. They could be overlapping, they could be on top of each other, they could be miles apart. But no matter what happens, they're the same line. So like co-working, whatever means with. Linear means I guess pertaining to lines. I don't know, liney. But if I select collinear, you'll see that kink went away. And now if I adjust this sketch, oops. I'm gonna take this circle here and I'm gonna click the lock button, which is a really lazy way to just keep something from moving. Normally you wouldn't really use it that much, but since we're tracing a photo and there's nothing to reference in the photo, we might as well just lock it in place. But you can see that no matter how I adjust this, it stays pointing at that center there, which is what we need in order for it to work. So yeah, and these two lines here, I want these to be parallel. So I'm going to select those two lines, and I'm going to select parallel. And I actually want to dimension this gap to be something specific, because it's going to have to interface with the 3D printer. So I'm just going to do 10 millimeters. Yeah, and if we wanted to, I'm going to do this and I'm going to undo it. If we wanted to make sure that this was actually inside of the 3D thing, we could do project and intersect. And what this is going to do is it's going to include that entire curve in our sketch. You see these purple lines? And then we can be like, oh, we actually have a problem here, which is that it gets really close to that edge here. So we can drag it in a little bit so it's not so it's even. Or we could even make this 8 millimeters, just so it has more body. The walls are thicker. Sure. I'm going to actually start the whole thing over. I'll show that again, and then I'll start the whole thing over. So under Create, we're still in the Sketch mode. This Projection Include folder includes a lot of things for getting sketch geometry from other things. And Intersect specifically lets you take something that's three-dimensional that passes through your sketch plane, and it takes a slice of that and gives you the information, access to those curves. So if I click Intersect, you can either intersect like faces with the default, but if you select the little bodies thing, you can select the entire body. And when you click OK, I'm going to make these other two components invisible by clicking on the eyes. You can see it. Then it included the purple boundary. Should I repeat that whole thing? With making all these lines? Probably, right? Or people rather we'll just do it on the video. We're not making this tool as homework. This is just like general tool making fusion practice. So it might not be important to follow along completely.
What happened if the dimension tool is keep the degree? Was that between the 10 millimeter thing?
Oh, like it gives 3 degrees?
Yeah. So it shows the degree on the.
So you can only do a dimension between a linear dimension if things are parallel. So I would undo the dimension, and then I would go into constraints. I would make the two lines parallel, and then I would dimension them. Okay, so I'm just gonna plow ahead. Again, making it 8 millimeters, moving it up a little bit, and I'm gonna click Finish Sketch. And now I can, using the regular fusion tools, I can extrude this thing. Notice that because this isn't a construction line, it thinks it's two things. So you just have to select both halves. I'm going to do symmetric because I want it to be in the middle. And then we're working off the midplane. And I'm going to do 0.5 millimeters. And it looks like we got some problems, Let's pretend that we don't care that it's flat, and in real life it's bent. You know, side cutters, diagonal flush cutters. They have they tilt up, which lets them, you know, grab the wires. You know, they have a bend in them. I'm not going to model that bend today. So for now, we can just bend it after it's laser cut with the lighter. I mean, not with like heat gun. But one thing I definitely want to do is I want to sharpen this edge. So I'm going to go to Modify and I'm going to go to Chamfer. And I'm going to just chamfer this to 1 millimeter, which is the thickness. But what I just did is I just typed the same number twice, which is a little weird because we could just use parameters for that. So I'm going to go ahead and add a parameter, just thickness. I can make it 1 millimeter. And we could do what we did before, where, you know, I went into this menu and I found all the things. We can also just go back in time here. I can right-click the extrude and do edit feature, and now I'm back in time. And I can do thickness. Oh, but that's 2 times as thick, so I can do thickness divided by 2. Or you could just do whole length and then thickness. Does that make sense? Because it's going both directions. And you can either specify the half length or the whole length. And then for the chamfer, I can also make that thickness. And the advantage of that is now if I go into Modify, and it turns out that there's only 2 millimeter material available, it still works. Oh. This is a complicated tool. Let's just pretend it's not. But I think modeling this for real would take a lot longer because you'd have to do not only the bends that it has here that allows it to cut flush, but also the bend that it has here that allows it to meet its friend. Because right now we're gonna have a problem where it's gonna be more like scissors and less like flush cutters. But let's just pretend it's scissors. Scissors work. They just don't work for this kind of thing. I'll show you what I mean in a minute. So now we have a chance to do all that again. So I'm gonna again activate the home component, the main component. I'm gonna do new component, and I'm gonna say bottom blade. And again, I'm going to do new sketch. Again, I'm going to use that same face. And this time, you know what? Actually, in this case, we don't need to do any of that. I'm just going to go Create, Mirror. I'm going to select the top blade component. And then for mirror plane, I'm going to select this bottom plane. I'm going to delete the component because I'm not using it. Wait. I'm getting a little confused. Oops.
You selected the plane that it's laying on?
Yeah, I selected the wrong plane.
Oh, okay.
So, sorry. We are going to... Okay, so... we're going to have to actually mirror it twice. Or we're going to have to... You know what? No, let's do this even easier way. Take top blade as a component, so you have the top level activated. right click it and click copy. Then right click here and click paste. Right click the name of the file on the top. And then we're going to grab it, we're going to spin it around 180. And we're just going to get it kind of close to where it's supposed to be, because we're going to finish this with other tools. And then we're going to click OK. So I'm going to delete this bottom blade because we're not using it. So again, we right-click top blade 1, we did copy. Then we right-click the name of our file and we clicked paste. And you notice that both of these are green. I hid the canvas by going into handle 1 and then tapping the eye next to the canvas. Notice that both of these are green. This isn't like some glitch. This is because they're the same component. By copying and pasting it, they're both top blade. If I grab, we talked about this in the first class, but if I grab something on one of these and change it, it's going to change it on both of them. Which is kind of what we want if we're making a scissor type thing. I'm going to go ahead and I'm going to ground this handle with the ground button so it doesn't move around. And I'm going to ground. No, for these two, I'm going to make a as-built joint between top blade 1 and mirrored handle, just so those are glued together. Now I'm going to make a regular joint between the bottom blade and the top blade. And you can just select, I'm going to do that again. You go to regular joint, and the first component is the one you want to move, and the second one is the one you want to move to, and it will snap you to all these different points, but in this case we have this nice hole, which is a great place to start. And it will snap those two things together. And by default, it's going to snap them together with rigid, but we actually want to snap them together with revolute, because then we can spin it around later. Now that that's in the right place, I want to make another as-built joint between these two things and have them be rigid. Now if I grab this, it's a tool. It's not side cutters. It's like weird scissors. But side cutters are too hard. That would take me a long time. Again, anytime you move something and don't mean to, just go ahead and push revert. It's kind of a jam-packed demo, but it's going to be online. There's two more things we have to do. We have to add the screw, and we have to, anybody see a problem with this model as it is now? Yeah. These two parts have a little bit too much in common. You know, we have to make that whole. And we have to add hardware. So let's make the whole first. If you go to Modify, very annoyingly, the tool that includes the opposite of Combine is called Combine. If we go to Modify Combine, you can select the handle as your target body and the blade as the tool body. Select Cut, and then select Keep Tools. And what Keep Tools is telling it is like, don't throw away the thing I'm cutting with. And now we have a hole. It's just that easy. Again, I'm going to do it for the other side. Modify, Combine. Target body is the thing we want to change. Tool body is the thing we want to change it with. We want to keep the tools. And this should still work. And if we go into the only joint, the rev joint, we can actually edit the joint limits, and then we can give it that springiness that we like. Cool. I'm just gonna finish up here quickly, and then I'll stop the video, and then I'll start reviewing. I just don't want to. I don't want the video to be too long. The next thing I'm going to show you is one of my favorite features. Who here has heard of Mcmaster-Carr? Cool, a few of you. Mcmaster-Carr, before Amazon, had the most items for sale of anybody in the world. But most of their items are like industrial and hardware based. You know, they have chains and pulleys and belts and shafts and tubes and hoses and clamps and solder and gas and tape and adhesives and glue and stock and cylinders. But they also sell a lot of hardware. They in fact sell pretty much every hardware. So I'm going to go to Insert. I'm going to click Metric. I'm going to scroll down until we find M3. I'm going to pick stainless steel. I'm going to pick I'm going to pick rounded for my head type. I'm going to pick hex for my drive style. I'm going to pick and for my length, I'm going to pick 5 millimeters. And this is, you can just insert anything, but, and to make this easier, once I actually make my selection, I'll just give you the model number and you can type it in the box. This looks great. I'm going to go to Product Detail and scroll all the way to the bottom, and then they actually have a 3D model of everything they sell. They have more than like 10,000 different types of screws, and they have a 3D model for all of them. So I'm going to select anything but SolidWorks will work, but I think SAT and STEP are the best. And then you click Save. And like, yeah, it's kind of janky that it just like opens a browser inside of your window. But now we have this. We have a screw. And you don't have to be that accurate with the placement because we're going to make a joint, but it's good to get it kind of close just to make things a little bit more straightforward. And then I'm going to do joint. Continue. I'm going to find it back where it was. And I'm going to select the underside here, that circle. And I'm going to select the top side here. And in this case, I'm going to make it rigid because it doesn't need to spin. And then if I wanted to, and I guess I do want to because it's a demonstration, I could go into Insert or Insert Mcmaster-Carr Component, Nuts. We're going to want to lock nuts. It doesn't come unscrewed while we're using it. Metric, M3, lock nut, stainless steel, nylon insert. Oh, they're all a little big, but whatever. It's just a demo. And then same thing. Save the step file. Enter. Joint. This time the bottom surface. There you go. It's really big. But let's just pretend that's okay. And you see like all these annoying little, these are visualizations of our joints, so we can hide those by hiding the joints. But yeah, it's a tool. And if we wanted to 3D print these handles and then laser cut these pieces, we totally could. The issue is I think the handles would require support, which is totally okay, so they might need to clean them up afterward. And on the inside, if I go to Inspect and then Section Analysis, when we print these, there's going to be these voids. But I think that since they're only 8 millimeters wide, the 3D printer will probably be able to handle those bridging those voids. What I don't think is going to be okay is I don't think that this is going to fit together. Because 3D printers tend to make holes too small and objects too large just by a little bit. And if my dimensions are accurate, there's just no way I'm going to be able to fit this 8 millimeter by 2 millimeter piece of plexiglass into a hole of the exact same size in a piece of PLA. So what we might, there's a couple ways of doing that. We could either shrink these down before we cut them, or we could enlarge the holes. Is there an offset body? It's offset face. I don't know what the best way of doing this is. Maybe we could do, give me a second, I'm going to do an experiment. There's a lot of ways we could do it. We could grow the thing we subtracted with, or after we're done, we can just go in here and we can just make these holes a little bit bigger. Like, I can use the push-pull command right here, and I can just be like, hey, this face, I want this to be negative 0.05 millimeters bigger. And I can just go around doing that with the press-pull command. Negative 0.05. And I could even better would be to modify parameters and to be like, press fit tolerance 0.05. And then I could go in and be like, okay, so can you select multiple? Oh, you sure can. And you can do negative tolerance. And on the same thing on the other one, press pull. Man, I've been using Fusion so long I've never realized I could select multiple faces. Think of the time I'd save. Negative tolerance. And if that were wrong, I could go back in, change parameters, and be like, no, it's got to be 0.1. And as soon as I push enter, those holes get a little bit bigger. They can even be much bigger. And then like there's a bunch of space in there, we could fill it with glue. Just like fill it with epoxy or hot glue and just smash it together. But I think 0.1 should be plenty. And now if I make everything visible again, you can see there's a gap. You know, they're not touching. Cool. So that is how to model these kind of obnoxious looking side cutters that are in fact scissors. Because real side cutters would be able to cut something flush, and this can't. This is more of a more of a hardwire cutter, but it's similar. I'm gonna stop the video.